Good, how are you?
Good. So, am I looking at what you sent me here?
Yeah, so we had a quiz, it was last week, and these are two problems I got wrong, so I
Okay.
got kind of confused on them.
Okay.
And then on the stuff we worked on last time,
Huh?
um, I didn't read the directions clearly enough, but it should be okay. It was just extra credit, but
I have
he wanted
I have the materials you sent me last time too. So if you want to go over any of this, we can.
okay, but with the extra credit, he wanted us to solve it with only using one variable. He went over it in class and it just didn't make sense to me.
So you're
So,
talking about the word problems.
yeah.
Ah, yeah. I was going to mention that you could use two variables or you could use one variable.
Yeah, I got kind of confused when he was explaining it in class.
You really have your choice. Um, Just say the second equation is x plus y equals 200. Okay?
Okay.
Well, you could turn that into x equals 200 minus y. And then you don't have two variables. You only have one. Wherever you see x, you can replace it. So there's always, or there's usually a way to do those with one or two variables. And I wasn't quite sure, when we were working on it, which way he wanted you to do it. I assumed it was two variables, but apparently it was only one.
Yeah,
Okay.
I was on the same boat with you on that one.
Um, I could certainly review any of those you want and use only one variable instead of two.
Yeah, I mean, if we could do like two problems just to
Okay.
make it clear.
Where do you want to start? Do you want to start where what I have open here, or do you want me to find the other stuff?
Um, let's just start with what's up now, and then we can do the word problems.
This is a calculator problem.
Ah, okay.
Uh, In other words, nobody expects you to be able to cube that number right there.
Okay.
Okay?
So all I had to, oh, I didn't think I read that.
Well, the difficulty here is it says round your answer to 5 places after the decimal point. Well,
Okay.
you can't do that if you do it early. In other words, you have. Do you still have a TI-84?
Yes.
Oh, thank goodness. Because I have a virtual TI-84.
Perfect.
I'm not sure. I guess I could do it on an Inspire. I don't have a virtual Inspire, so it would be hard for me to do it on an Inspire. Uh,
So I think what I got confused on was that like I was trying to reduce it first and then get the square root of all of it.
well, here's the thing. This is not probably as easy as it looks. There is a certain amount of reduction that you could do. Okay? In other words, minus 4 squared is 16.
Yeah.
Okay? Minus, now, if I go ahead and do this in my calculator and put a number in there,
Mhm.
okay, but I have to round it to more than 5 places. If I only rounded, I noticed that when you did it, you only rounded that number to 2 places.
Ah. Yeah.
That's the problem.
Gotcha.
When then you then do the subtraction and you take the square root, and even if you take this answer and round it to 5 places, it's liable not to be correct because you have a round off error. In
Right.
other words, even if I rounded this number to 5 places, I might not come up with the exactly perfect answer.
Right.
Okay? So, we can do this one of two ways. You can take this number and round it to like 7 places,
Mm-hmm.
and then take the square root of that and round it to 5 places. That almost certainly is going to give you the right answer. But the better way to do it is let's take all of the guesswork out of it at once. So if I want to rewrite this expression such that I can put it into a calculator all at the same time, then I'm going to rewrite it as this.
Okay.
So this is the way I want to put it into the calculator. Then, whenever I get my answer, I'll just round it to 5 places. So
Okay.
let me show you how to do that. So we're going to take the quantity 16 minus the quantity 1.86. Watch how it appears on my screen.
Mm-hmm.
I'm going to raise that to the 3rd power. Notice
Mm-hmm.
I'm only raising that quantity to the 3rd power. Now I need to take that whole thing to the 1/2. So I need to put a parenthesis there, and I need to go back to the beginning and put an extra parenthesis there, because you always have to have balanced parentheses. Ooh, it didn't put one, did it? Hold on. I have to insert. Where's the insert key on this thing? It's second. What? Hold on a second. Let me pull my regular calculator. Doesn't work, but at least I can read the keys on it, and I can't always read them on this. How do I insert a parentheses?
What I do is I just erase the whole thing and do it again.
All right, I'll do that. So I want to insert another parentheses and then 1/6 minus parentheses 1.86 end parentheses raised to the 3. And now to see if we have the right number of parentheses, I have a total of 3 on the left, correct?
Yes.
I should have 3 over here, and I do. In other words, you always need, if I have 3 going to the right, I have to have 3 going to the left.
Okay.
Okay? Now, that whole thing I want to raise to the 1/2 power. Well, I can make that 0.5.
Okay. And then you get...
Now, as to whether or not we get an answer that's close to being correct, notice that you got 9.57.
Right.
But then we have to take the square root of that.
Yeah.
And round it off to 5 places. Well, you can see that this is probably not going to give you accuracy to the 5th place, because you rounded it off to the 2 places.
Yeah, that's why.
This, yeah, exactly. So now this answer here, I can round off to 5 places. So that's 3.09276.
Okay.
Okay. Now, just for curiosity's sake, let's take the square root of your answer and see what we get. 9.57 raised to the 0.5, 9.09354, not even close.
Yeah.
In other words, there was a lot of round-off error.
Yeah.
So the way to treat round-off error is to make sure you either don't round off before you get to the end. Or if you absolutely have to do it, in other words, if you cannot figure out how to do that on the calculator anyway but solving that first, round that off to like 7 places.
Okay.
Then, when you take the square root of it, it'll be the same answer as you would have gotten had you done it this way.
Okay. That makes sense.
Well, same thing with this. Now, in other words, you have two choices here. We could take the square root of 3.8, but we would want to round it off to like 7 places.
Yeah.
And we could take pi squared, round it off to 7 places. Then when we divide the numerator by the denominator, which will each have been rounded off to 7 places, we'll get a number that if we round it off to 5 places, we're probably okay. But what you cannot do is round it off before you get to the final step, which is what you did here.
Yeah.
In other words, you rounded that off. Okay, so let's see if we can figure out how to get the precise answer on this calculator. Well, let's see. I want a numerator divided by denominator. So I'm going to put parentheses around the numerator, and then I'm going to put double parentheses because I want to take the square root of 3.8. And let's see, and then I want to subtract 1.76. So that is my numerator.
Okay.
And then I want to divide by my denominator, which I'm going to say 5.4 minus pi squared. So I only need one set of parentheses. 5.4 minus, the pi key is this one here. Yeah. Second pi raised to the 2 right parent. Now study that expression for a moment. Always work from the inside out. In other words, what's happening here is I'm squaring 3.8. Oh, I'm not squaring it. I'm taking it to the 0.5 power, which is taking the square root of it. Then I'm subtracting 1.76. And then I'm taking that quantity, because these parentheses are on the outside, and I'm dividing the whole thing by the quantity, parentheses, 5.4 minus pi squared, parentheses. So that should give us an exact answer that has not been rounded off at all. In other words, pi, they're going to give you that, to 20 digits. And they'll give you the square root of 3.8 to 12 digits. So if I hit enter here, okay, I got a negative number. I got something very similar to what you got. Notice that if you take this number and divide it by 4, you get 0.04. It's negative. So that means we did it correctly. In other words, the work you did here is not entirely for naught. It tells us approximately what we're looking for. The only problem with this answer is it's not going to be rounded off to 5 places properly. Okay.
Right.
So write this down. The correct answer is negative 0.04237.
Got it. Okay.
Now let's take your answer, 0.1894, and divide it by negative 4.45, and notice the difference in the two answers.
Yeah.
This first one is correct if we round it off to 5 places, but even if we take your answer and round it off to 5 places, we don't get the same thing. And the reason is that you've got round off error. In other words, if you have a complicated expression and you round off before you get to the end, sometimes that round off error accumulates and you don't end up with the correct final answer. And this is a perfect example of it.
Okay. That makes sense.
So, you'd have been okay, and in fact, let's do it. I think it would be useful for you to see if I want to do this. In other words, it's not that easy to get this into the calculator properly, right?
Yeah.
So that's why everybody does it. In other words, they figure out what the square root of 3.8 is, they figure out what pi squared is, and then they try to do it. Well, that works if you round it off to more than 5 places. So let's take 3.8 and take the square root of that. That's 1.94935, and I'm going to go out to 7 places.
Okay.
Now I'm going to subtract 1.76 from that. So that gives me and I'm going to keep it at 7 places. Okay. So if I wanted to do all of this problem in separate steps, I could do it. Just make sure you exceed the number of places that the final answer needs. Okay, now I need to divide that number by 5.4 minus 5 squared. 5 or minus pi squared. And let's figure out what pi squared is. Seconds, that squared equals 9.8696. And again, we want to make sure we state this to at least 7 places.
Okay.
Okay. So now, if we solve the problem this way, then I still have to do this subtraction.
Right.
Let's do this subtraction really quick. Because I have that answer already to 9 places, it's not that hard to do that subtraction. Let me subtract 5.4. Even though I'm going to get the wrong sign, I can change the sign, okay? So now my denominator is this number minus 4.469604. Now if I go into the calculator and divide this numerator by this denominator, I should get the exact answer we got before. Well, once I round it off. Let's see if that happens. 0.0893588 divided by a negative 4.469604 equals, and like all math problems, if you make one mistake on it, you don't get the right problem. You don't get the right answer.
So it's just easier to put parentheses around it and put it into your calculator.
It's much easier. It's much. Now, let me ask you something. Do you have to be doing these on your calculator, or can you use a smartphone?
He prefers a calculator.
Well, the reason I ask is because there's this terrific website called Wolfram Alpha.
Oh yeah, I remember that.
Well, if I try to put that function into Wolfram Alpha, it will tell me exactly what I'm putting in. And I won't have to second guess myself as to whether I'm putting it in correctly. So if you have a chance to use Wolfram Alpha on problems like this, by all means do it. I'll show you exactly what I mean. I hate to take up so much time on this, but this could really be worthwhile to you.
This helps actually a lot to see this.
Okay, there's my numerator, minus 1.76, divided by my denominator, which is 5.4 minus pi squared. Now, I don't have to worry as to whether I put it in correctly or not, because it's going to tell me how I put in. Something your calculator does not do.
Right. Yeah, I remember using this. He showed me it in high school.
Notice that I did not put it in there correctly.
Right.
Okay, in other words, it doesn't have this square root of 3.8 completely in the numerator. So, how can I fix that? Let's go back and put parentheses around that, put parentheses around that, and I think that'll fix the problem. Yeah, now you have exactly what we want. And this ability to show you what you input is huge, because it's very, very difficult to get all of the parentheses properly on your TI-84. So if you have the ability to use Wolfram Alpha when you take these quizzes, by all means do so. It'll be so much easier for you. You see where it gives you exactly what I put in, and I can check it against this to make sure, yeah, that's what I wanted to put in.
Yeah.
Now round this off to 5 places, and you're in like Flint.
Okay, that's really helpful.
Yeah, it actually is. If you have the ability to use either Wolfram Alpha or a calculator that shows you what you're putting in. I mean, the TI-84 is a great invention for its time, but it doesn't show you what you put in. And for complicated expressions, that's pretty problematic because it's hard to get it in there right. And with Wolfram Alpha, you'll notice I didn't get it in there right, but it showed me that, so I was able to go in and fix it.
Yeah.
All right. So, okay. So,
still have those word problems we worked on?
Yeah. Let's see if I can find them. Are these them?
You can just choose a random one if you want.
Are these the correct ones? I think they are, yeah.
Yes, those are. You can choose a random one because he was explaining it.
I know exactly what the problem is.
Okay. And also in class with, I think it was number 5 with like the solutions and stuff.
Uh-huh.
It's just another technique with like a chart, like a box kind of formulated way. Would you like me to send you a picture of it really fast?
let's first of all go through number 1 using one variable only. And then, wow, these are such two variable problems.
I know. That's why I was like, I don't know what you're talking about.
Well, sometimes it's worth using one variable only because it makes it easier. But these problems are not that easy to use one variable. However, let's do it. We can do it. If the perimeter of the rectangle is 48 inches, well, that means 2x plus 2y is equal to 48.
Right.
The width is 6 inches less than twice the length. So the width, x, is 6 inches less. Now hold it. The width is y, excuse me. Okay, that's the way we did it.
Right.
Well, the way he's saying you should do it is instead of even creating a variable y, we should just solve this with one variable.
Right.
In other words, it's 2x plus, instead of y, we're going to write 2x minus 6 equals 48. And that's how we did it. It's just that we used the concept of two variables. And he's saying do this with one variable. No, hold on a second. Let's look at number 2. Number 2 makes a lot more sense in one variable.
Okay.
We're going to let x equal the number of $30 tickets purchased.
All right.
Well, instead of making a second variable and calling it y, why don't I just let the second variable be 210 minus x?
Okay.
That's the number of $65 tickets purchased. You see how we got that? In other words, by knowing that 210 tickets were purchased, if x is the number of $30 ones, then 210 minus x has to be the number of $65 ones.
Right.
Now I can write one equation only. It's $30 times x plus $65 times 210 minus x has to equal the total revenue. And then we solve that as one equation only.
Okay, I see what he's talking about now.
That's what he's talking about. And it's really clear on number 2. You could do number 2 either way, using one variable or two variables. The problem is that takes quite a leap. And notice the difference. When we did it the first time, I said let y equal that. Right?
Right.
But then I had a second equation, which was x plus y equals 210, which means y equals 210 minus x. So that was my y. It's just that we kind of skipped a step when we only did it in one variable.
Yeah, I see it.
And it makes a lot of sense in this problem to do that. In other words, a lot of people can make that jump. And if there's 210 tickets sold, then 210 minus x equals the number of $65 tickets bought.
Yeah.
Then you only have one equation and one unknown, and you do not have to solve it as a system of two equations. But this step isn't always so easy to see. And in fact, in problem number 1, It's not that easy to do problem number 1 as a one variable problem. It's very, very easy to do it as a two variable problem. Why? In other words, if I try to do it as a one variable problem, how do I do it? It's not that easy. The second problem, it's really easy to say that the second variable is 210 minus x. In the first problem, it's not that easy to say that. There's no simple way to figure out the second variable.
Right.
Because perimeter is twice the width plus twice the length.
Okay.
Okay. Now,
This makes so much more sense now. I think he was just going over it a little bit too fast.
well, number 3 I could easily do as a one variable problem. Remember what we did on number 3. I said let's let x equal the amount of money invested at 8%. And then what I said was let's let y equal the amount at 6.5%. Well, wow. He wouldn't have said that. He would have said the second variable is $14,000 minus x. That's the amount invested at 6.5%. In other words, he is already doing a calculation to come up with that second variable. From the very first sentence, it says we invested $14,000 in 2 accounts. Therefore, if x is the amount we invested in the first account, 14,000 minus x is the amount we invested in the second account. So, as long as this step is one you can come up with, then you don't need to use that second variable.
Right, okay.
Notice if I do use the second variable, one of my equations is y plus x equals 14,000, right? And then I'm going to use substitution to solve it, which means y equals 14,000 minus x. So when you try to turn it into a one variable problem, it merely means you're solving one of our equations first.
Right.
To me, it really doesn't make sense to teach these as one variable problems. It makes sense to teach them as two variable problems and just come up with 2 equations that you have to solve. If you try to do them as one variable problems, they actually are a little more difficult because you don't do this step here. You accomplish that in your head to get that step there.
Right. Okay.
Okay.
You explained it a lot better than he did.
It's something I've kind of been faced with for years because all my algebra students have these word problems, and most of them can be done as one variable or two variable. The problem is when you try to do them as one variable, it requires that leap. In other words, this leap right here, where you have to figure out the second variable is 14,000 minus x. Now,
right.
let's take a look at, I wanted to say something on question 5 that I didn't really get a chance to say. And let's talk about that before we even go on. When you're dealing with liquid solutions, like acidic or saline or whatever else has been dissolved in water, it's best to treat everything as it's a solid.
Okay.
Okay. Let's see if we can do this as a one variable problem. X, what quantity should you use? So X is going to be the amount of 10% solution. Okay. and I have to end up with 20 quarts. So what is the second variable?
So wouldn't it be 20 minus x equals the amount of 50% solution?
Okay. Now, here's this final solution we get is difficult because, well, I think if I write it, you'll understand. The amount of acid, not acid solution, but the amount of acid we start with has to end up with the amount of acid we end up with, correct?
Right.
Well, the amount of acid we start with is 0.1 times the amount of 10% solution.
Yeah.
Because that 10% solution, 10% of it is acid. So if we were to dissolve 90% of the water, we would have acid only. So if I add that amount of acid to 0.5 times the amount of the 50% solution, that's the total amount of acid we have to begin with. Not acid solution, but acid.
Right.
The amount of acid we're going to end up with is 0.4 times 20. Right? Because we want a 40% acid solution. So the amount of acid we have to end up with is 0.4 times however much solution.
Right.
So we start with that much acid in the 10% solution. We add that much acid from the 50% solution. Has to be equal to the amount of acid we end up with.
And that should be 8.
Right. In other words, this is easy. It's not solving these that's hard. It's formulating them. And notice that we only have one variable here. In other words, we have an x variable. So this is going to be very easy to solve for x. X is the amount of 10% solution. What they're asking for is the amounts of 10% and 50% solution. Once we solve for x, we're going to be able to solve for the second one by just taking 20 minus x.
Right. Okay.
But the key on these solution problems, they're the hardest ones, except for maybe number 4, because on number 4 you have to know dirt, D equals RT. But on the solution problems, you have to think of it as a solid. If you took a tablespoonful of salt and dissolved it into a quart of water, you would still have a tablespoonful of salt, right? Even though it was dissolved into water. I mean, I don't know what percent solution that would make, but it's helpful to think about it as you still have a tablespoonful of salt. And if you add it to another solution that has salt dissolved into it, what you want to figure out is how much salt, actual salt, that other solution has, and make sure that when you mix them together, the amount of salt's not going to change. Right? I mean, if you have an ounce of salt in the first one and you add 2 ounces of salt with a second solution, you're going to have 3 ounces of salt in your final solution. I don't know what that solution will be. It depends on how much water you have with it. But I have found that these solution problems work best when you actually treat them as a solid dissolved in water.
Yeah.
Because acid isn't that. Acid is a liquid mixed with water, but it's easier to think about if you think about it as being a solid.
Right.
Because the key part of this is the amount of acid from the one solution added to the amount of acid from the second solution has to be the final amount of acid. And that's why the right side of the equation is 0.4 times 20.
Right.
All right. You want to, shall we look at number 4 as a one variable problem?
I mean, we can. I don't have a problem with it. I think I get it now with the whole, like,
Okay.
one step thing.
Okay.
But
So,
whatever.
what else? When you want to go back to anything else?
That's basically all I had questions on. I stayed with him after class last week to discuss those other problems that I sent you, like, last week.
Okay.
And I talked to him about it, and he explained it, and I actually got those right on a quiz. So
you're good to go. The only thing about these is don't round off until the end. And if you have to round off before the end, round off to much more places than they tell you to.
Right.
In other words, if I round that off to 7 places and I round the bottom off to 7 places, even after I make the division, my round off error is still probably going to be accurate to at least 5 places.
Right.
I wouldn't want to round the top off to 5 places and the bottom off to 5 places, because then when I do the division, I might end up with some round off error that changes my accuracy. So the best way to do these kind of problems is to put them in the calculator all at once. The difficulty with that is knowing whether you got it in there right.
Mm-hmm.
So really the best way, if my life depended on doing these, I would do them in Wolfram Alpha every day.
For sure. I'll definitely use that, because I remember using that
if you have
in
the
high
ability.
school.
If you have a smartphone and he lets you use your smartphone, then just point it to Wolfram Alpha.
Yeah, I think I'll do that on homework and
Just
stuff.
make sure that when you do it, you check. You'll notice that when I did it even on Wolfram Alpha, the first time I got it in there wrong.
Right.
I had this all alone, not as part of the numerator. So to make it as part of the numerator, I had to go back in and add an extra set of parentheses. So, I mean, there still are some difficulties regardless of how you do it. But perhaps if my life depended on it and I couldn't see how I put it in, I might just do that and round it off to 7 places and write it on a piece of paper and do the math. You know what I'm saying?
Yeah.
Just the only mistake you can make is to round it off to 2 places previous and then try to round it off to 5 afterwards. That does not work.
Right.
All right.
Perfect. Well, I think I got it. Next Tuesday, I'll probably have more stuff to kind of review.
Okay.
And it helps that I have our sessions right before my math class, because we have a test on Tuesday. Cool. So I'll have more material to go over, and so I'm prepared for class.
Cool. Now, I had one last thing I wanted to talk to you about.
Yeah.
I've thought about this idea for 6 years, but I've never figured out how to implement it. So I thought I would ask you if you have any desire to participate at all. I'm trying to expand my business, okay? Beyond Colorado to other online students.
Mm-hmm.
I figure the best way for me to do it is to get my current students to refer me to their friends.
Okay.
Well, I imagine you're a pretty popular girl. You must have a lot of friends at that school. You might be able to find some other people that need help also and wouldn't mind doing it.
Yeah.
So what I thought I would do would be to reimburse you at $5 per hour for every hour that a student signs up and pays me for. In other words, if you tell somebody about me and they tell me you told me, and I do $200 worth of business with them, you would get like a sixth of that.
Okay. Cool. Yeah.
Now,
I will definitely
yeah,
think
the reason I've never been able to put this into effect before is because usually the parents are paying, so it's never made a lot of sense for me to reimburse the student.
Right.
It would, I would reimburse the parent. And the problem with that is then the student doesn't have a whole lot of motivation to go out and find me students. So
Right.
here's what I would want to do is I don't know if you have a PayPal account. Do you have your own PayPal account?
I do not actually, but I could always set up one.
You could open one up. And I mean, there's no cost to open one up. And then whenever I had a student who paid that was referred by you, I would automatically go in and make a $5 payment to your PayPal account. And, it's not going to add up to a lot of money, but that's why I asked if you were working. I don't know whether money is when I was in college, I always needed money. My dad was helping pay for my college, but I played poker on the side to make money. So I always supplemented my income. So if you're interested in doing something like that, let me know. I would run it by your father since he's the one I'm sending your bills to. And
Okay.
I would want to keep it as two separate accounts. In other words, I would not want to just deduct from his bill because that doesn't give you any money.
Right.
And I want you to be able to make money so that you could, you're motivated to go out and find people as students for me.
Yeah, of course.
But I won't do anything further. I will let you think about it. And if you want to pursue it and you find at least one student, tell me about it. I'll tell your dad about it. If it's okay with him for me to do it the way I'm talking about doing it, we'll proceed.
Perfect. Yeah, I'll definitely think about it and try and find a few people.
Yeah. I mean, if you were working a job, you'd be probably lucky to get $10 an hour. So this is something where you'd be making $5 an hour every time I did an hour session.
Yeah.
Without doing anything. So might be something that you would find appealing. Depending on how many people you know that might be interested in doing this. Now, they would have to pay in advance. I should add that. Most anybody that's outside of Colorado, I do require to pay in advance unless there's somebody that I worked with in Colorado.
Yeah.
That I have a relationship with. So I'm fine with billing your dad for your sessions, but for anybody else that came, they would also still get a half hour free first session that
Okay.
you wouldn't be billed for. They could find out what it's all about and see how it works. But then after that, every time they pay me, you would get $5 per hour. My rate is $32 per hour, so you'd get about a sixth of whatever I was making.
Okay, cool. Yeah, I'll definitely look into that and let you know if I find anyone.
If it works for you, fine, we can pursue it. If it doesn't, it's no big deal. I mean, maybe that's not even enough money to be.
$5 can buy me a cup of noodles, so that'd make me happy.
All right, Taryn.
All right.
I will talk to you next time.
Sounds good.
All right.